right. So, Mr. Mick, are you ready for our next lesson in the Sugaku?
I'd rather play some video games today.
Oh, okay. Let's do that. So, we want you to watch this video. And then, so I want you to watch. Oh, why isn't it doing that? There we go. We want you to watch the video, then pause our video to talk about what type of transformations you saw in this video. So, let's go ahead and do this, and we'll put the video on the next screen. Okay, so hopefully this works. Here's the video to watch.
I love when technology works.
I'm seeing a few transformations in here.
I do too. I'm looking to see if I see more than one.
Yeah, I mean, I definitely see one. I definitely actually see two.
Yeah, two for sure.
Two for sure. I'm hoping I get to see a third one. But then again, I don't know about you, but when I played this game, oh, nope, that was it. So you definitely saw two of them in there. Pause the video and talk to your neighbor and see which ones you saw in there.
Okay, Mr. Cass. I saw translation from our first lesson. He was definitely sliding, or she was sliding around. But there was a new motion, like turning or rotating.
Rotating. You know what? That is our next lesson. It is rotations. Ah, there we go. That was an old song.
That was an old song. I was in 6th grade when that one came out.
That was, I know. I think so too. It was when we were growing up, when we were their age, I think.
Exactly.
Oh my gosh. Well.
About that.
About that. All right. Anyways, so if you listened to the song and you heard the song, you heard him talking about a record. Stop. And, well, yeah, we'll make it a little bigger so they can make sure. That is called a record. I mean,
kind of like a CD, but from long time ago.
I don't even know if they would know what a CD is.
Oh, gosh.
But what they talked about was the fact that this would turn, and you could turn it like a record without it getting bigger or smaller. That's just my fingers doing that. But it was a rotation. That is a rotation. Let's actually define that for them properly. How about that?
I like it.
So, we are going to do here, we're going to write, there we go, a rotation is a transformation in which a figure is rotated or turned about a fixed point called the center of rotation.
Hey, Mr. Cass, that's like that hole in the middle of the record. That is the point that it would be rotating on, right?
That's right. That's the fixed point. Doesn't change. Doesn't move.
So what are we going to be doing in our math class? What are we going to be rotating around? There's not a center of a record.
I guess we're going to have to pick a certain point that we can go around and always go around that point.
I like it. Let's see how that works.
Okay. But one more thing about rotations that we've got to know. Do this real quickly. Since the figure, unlike my record, does not change size or shape, it keeps going around, the record never changed sizes, it never changed shapes, it was always the same.
It was a circle.
Yeah. The pre-image, oops, I spelled that wrong. The pre-image and the image will be congruent. Now, is that the same with translations and reflections too?
Translations, they did not change size. That's true. And then reflections, same thing. They did not change size.
They just changed orientations or the way they were moved and stuff, so they're always going to be congruent.
Couple of vocabulary words we need to get started here is we need to talk about clockwise and counterclockwise. So here, let me grab here. Here is the center of my clock. And this hand over here that you guys are always watching during class goes this way when it's going round and time's going forward. And this hand goes backwards if time started to move in reverse. So we call this clockwise when we rotate, and we call this counterclockwise when we go backwards. All right, that's the first thing we need. Now we're going to actually rotate visually about the origin. Okay, we're ready to visually rotate. I'm going to start with a triangle. I'm going to make, let's try there. Let's make point A here. If I didn't get the pen again. Any ideas? Oh, there we go. There we go. Point A. And we're going to make this one point B right here on the x-axis. And we're going to make point C at the origin. So we've got a right triangle. We had a lot of experience with those. Okay, I want to rotate this. Yeah, I don't know why the pen doesn't like me.
The pen's not being cooperative right now.
Rotate around. Rotate around. Oh, I should have written the word clockwise. I'll get that in there. Rotate around the origin clockwise. So just like that second hand on a clock. Okay, changing colors. Remember my final image is going to have primes on it. And when I actually take this piece, I think I can do this now. How did you do that?
You gotta switch to that.
Okay.
There you go.
And when I do this, well, there's a rotation, but that's not exactly what I wanted. Let's try this again. All right, got my red pen. I'm going to move this. This is at 0, 1, 2, 3, 4, 5, 6. A is at 0, 6. And I want to go ahead and now it's going to be over here at 6, 0. 1, 2, 3, 4, 5, 6, 0. That's going to be A prime. So A prime. Ooh, look at that. 6, 0. It's kind of a pattern, right?
I wonder if that holds as a pattern.
I wonder. Well, we'll see. I want to get, this is an eraser, right?
Yes.
I want to get rid of this. This is in my way.
It may not erase.
Oh, and it won't erase. All right, we're going to live with it. Now we're going to do, let's do C. Interesting thing about C, when it rotates, it actually doesn't move. So C and C prime are the exact same point.
Is that because I'm rotating around the origin and C's on the origin?
That's right.
Okay.
Exactly. If you think about the North Pole, when it goes round and round, its position doesn't move because everything moves around it.
Like the record, that center hole just kept staying, even though we rotated around it, it stayed exactly where it was.
All right. And then B is going to be 2 down here, B prime. It's going to be there. So this is what it's going to look like when I rotate 90 degrees clockwise around the origin.
And that kind of looks like when you move the picture, it does look like that this triangle fell over on its side there.
And just in case I should list these, let's see. B prime is at 0, -2. And C prime is at still the origin. All right.
So there we go. Let's look at this picture here. And in this picture, we actually have an L, the blue L, which was our pre-image, and the L, which is our image. And this was our pre-image to our image, so it's already been rotated for us. But let's take a point, for instance, like let's take this point right here. And this is the point, what is it? Call that point A. And point A is the point 3, 2. Now we know if we rotate the picture that this here is going to end up being A prime, right?
Yeah, that's excellent.
So A prime ends up being the point 2, negative 3. Let's look at another point just for fun to look at one. Let's look at this point right here at the top of the L. Right now, call that point B. Point B is at the point 1, and it's up 1, 2, 3, 4. And if we look at that same point on the red L, call that B prime, that's at the point 4, negative 1. So as we look at that very carefully, I'm wondering if we notice any type of pattern or uniqueness in something going from A to A prime or B to B prime.
I see a pattern. The numbers are the same. It just looks like the numbers have switched positions, and then it looks like it's always the opposite of the Y term.
So a 90-degree clockwise rotation, if I have a point XY in my pre-image, then it looks like that's going to go to, I'm going to put the Y where the X is,
Ooh.
because it looks like the 2 went to the X, the 4 went to the X, and then the 3, the original X, went into the Y position, and the 1 went into the Y position, but except it became its opposite. So it became negative X. So I have a 90-degree clockwise, the original point becomes Y negative X.
That's really cool. Will that work for every 90-degree rotation clockwise?
That will work for every 90-degree rotation clockwise. Matter of fact, we have some other ones that we can talk about. We're going to go clockwise. We're going to have, and actually I want to move that down a little bit. We're going to say we have the point XY. That's the original point. We're going to turn it clockwise, and we're going to have our new point, our image point. So, for example, if I go 90 degrees clockwise, we just found out that it's Y negative X. We could also go 180 degrees clockwise.
Would that be like going 90 degrees and then going 90 degrees again?
It would be. So if we went 90 degrees and then 90 degrees again, it would make sense that the Y would go to the X position, so it would be negative X. And then the Y would go to the X, which is the Y. And it's kind of confusing on that, but the Y goes into the Y position, but it goes the opposite, so it becomes negative X, negative Y.
So when you have your pre-image and you go 180 degree clockwise, it's just the opposite of the X and the opposite of the Y. That's actually easier, I think, than 90 degrees clockwise.
I think so. 270 degrees, we'll just tell you, is negative Y X. So if I'm turning it 3/4 of the way around the circle, I know, I just made that motion, like you can see my motion of that. But I would go 3/4 of a way, and I get that. Now, here's the cool one. If I do a full 360-degree rotation.
Wait, you're right back where you started.
I'm right where I started from. So it's just X, Y. Now, here's kind of the coolest thing. What if it's not clockwise? What if it was
counterclockwise?
Counterclockwise. It was the opposite. Well, if you think about that for a second, if I go, and let's take a little graph there. If I went 270 degrees clockwise, that's 90, 90, and 90 is 270. That's the same as if I'd gone 90 degrees counterclockwise.
You're in the same position whether you go 270 clockwise or 90 degrees counterclockwise.
So it would make sense that this would be 270 degrees counterclockwise would be the same thing as 90 degrees clockwise. So I'd get the same point.
So I can use the same formula for 90 degrees clockwise and 270 degrees counterclockwise.
Absolutely. or 180 degrees. Clockwise or counterclockwise is the same thing. It doesn't matter.
Oh my gosh, that's interesting.
This would be 90 degrees. And of course, this would be 360 degrees.
This is so important. I think on my notes I would highlight this or put it in a box, probably even put it on a 3x5 card on my...
I think this would be perfect to put on a 3x5 note card. And this only works, by the way, only works when you're rotating about the origin. Now, in a future class, you might learn how to rotate around a different point. This doesn't work that way. But
Yeah.
it only works if you're going around the origin. There we go. Okay, so here's what we want you to do. We want you to look at this problem, pause the video, try it, and then we'll show you what the answer is afterwards. But if we gave you the following 3 points, D was negative 4, 4. E is negative 1, 2. And F is negative 3, 1.
Now, did you mean to put D prime there?
Oh, I did not mean to put D prime there. I don't know why I put a prime there.
There you go.
Just the D, just the image. And we want you to rotate this 90 degrees counterclockwise.
Time's going backwards again.
So think about what would D prime be, what would E prime be, what would F prime be if you rotated this 90 degrees counterclockwise. Pause the video, and then we'll come back with the answer. All right, so let's see how you did. If you remember, 90 degrees counterclockwise took the point and turned it into negative y x. So that means D, which was negative 4, 4, became D prime, where we took the y and made it negative. So the 4 becomes a negative 4, and the x stays the way it is, so it becomes negative 4.
Right, now it looks like that first negative 4 stayed the same, but actually they moved positions.
They did move positions.
Kind of a coincidence that it's another negative 4.
Yeah, let's look at the E. E, this one might be a little bit more obvious. To E prime, let's see again. We take the y and make it negative. So we take the 2 and make it negative. And we take the x and we leave it alone, but we put it in the y's position.
Yeah, so it was negative, so it's still negative.
So it stays negative.
Yeah.
Good. F, if you did it right, you took 3, 1.
Negative 3, 1. Yeah.
Negative 3, 1. Not seeing my negative signs. See, even I do that, but you're not going to do that. So negative 3, 1, and we're going to make that F prime. And what will that become? That will become negative 1, because the y becomes negative, and negative 3, because the x stays the same.
I like this. I think it's going to take more practice. Luckily, we're going to get more practice.
We're going to get a lot more practice. Matter of fact, we're going to give you a problem now. Oh. There we go. We're going to give you a problem now. And this is the problem that you need to come show us when you have it done, showing us that you actually have the video watched and done. So we want you to take the point 5, negative 3. And we want you to rotate that clockwise and tell us what happens if you take just that point and you rotate it 90 degrees clockwise. Where would it end up? 180 degrees clockwise. And where would it end up? And 270 degrees clockwise. And where it would end up?
So, Mr. Cass, this is 3 separate problems. You want me to take the point 5, negative 3 and rotate it 90 degrees clockwise and get an answer, 180 degrees clockwise and get a separate answer, and then 270 degrees clockwise and get a third answer.
Yes, and always starting with the point 5, negative 3. So these are 3 separate problems, all related back to this original point. We always want you to use that point. So first rotate it 90 degrees. Go back to the original point. Rotate it 180 degrees. Go back to the original point and rotate it 270 degrees.
Okay, I can't wait to see their answers.
Perfect. And that ends our lesson on rotations.
All right. That was a high five.